Steve. How's it going today?
Very good, David. How are you?
Good. Doing well. I'm excited. This is we're just chatting right before this. This is two Irishmen in 2 weeks in a row. Although you're living in Mountain View, which is where I lived for 14 years, so we have I guess two sources of connection.
Small world, and I see some folks from Ireland in the chat as well. So always nice to see the homeland represented.
Awesome. Yeah, we have a very international audience, which always brings me joy. So this topic is quite an interesting one: safety at speed, finding the balance between quality and speed. Before we get into that, first I want to mention to folks, anybody can ask a question in this Q&A. So feel free, on the side of your screen, you'll see the Q&A tab. Ask any questions that you want. They can be particularly on the topic, or if you think that's something relevant that Steve might know. He's the head of cloud engineering at Atlassian, so I know he's been around the block. So feel free to ask anything, and in the meantime, we'll have some starter questions. Also, if you don't have any questions yourself, you can still upvote questions from others. So feel free to do that. So kicking it off, Steve, you just want to tell folks a little bit about yourself?
Sure. So I'm responsible for engineering at Atlassian. So I have all of products like Jira, Confluence, Trello, Bitbucket, as well as running infrastructure, operations, and platform and things like that. I'm based in Mountain View out in California. Before this, I was at places like Groupon, where I was running all the international operations as well as some of the North America platform and data infrastructure. And then before that, I lived in Boston for a few years at VMware, doing virtualization of mobile phones, which was fun. I could bring up a couple of examples later. And before that, also in Boston at EMC, back when people thought about things like rack stack storage and things like that. So always been kind of living at that intersection of software, infrastructure, operations, and really enjoy it. Just love technology, love spending time in that space when I'm not too busy chasing my two little daughters around the place. So that's what keeps me busy.
That's awesome. And we have even more connections. Obviously, probably like many folks that are listening, I've been a user of Jira for many years and Atlassian products, Confluence, etc. So you have celebrity status in and of itself by running the team there. And then I lived in Boston as well for a little bit. So
okay. So we can commiserate about the snow later.
I know. Oh, indeed. Excellent. Well, so this topic being about finding the balance between quality and speed, I'd certainly love to hear your perspective, because not only do you have this direct experience from building product at whether that be at Atlassian, Groupon, et cetera, but also I imagine building products that are used for people to build things effectively and more quickly and with quality, et cetera. I imagine you may have even some deeper insights. So yeah, how do you go about finding the balance between quality and speed?
It's a lot of it comes from experience. So I wish I had some of these insights before some of the incidents we had and some of the issues that we had. Are you still there, David? There you go. Okay,
yeah,
cool.
I'm still there.
Yeah, so yeah. I think the way I think about it really is there's a spectrum, and I'll give you an example. Right, when we were at VMware, one of the things we did was we provided source code to phone manufacturers that got compiled into handsets that never got an update. And so when you think about safety in that context and reliability, you have one shot to provide the code and you will never see it again. And some of the liability insurance of those cases are pretty onerous. So the mindset there is very different than, let's say, if you're working on a consumer website where you're trying to iterate quickly and learn with large amounts of traffic and experiment. And then at Atlassian, where we're providing enterprise software and teams, really run their business on our software, we want to kind of find that balance between the two. I would say that the things that I've learned and some of the insights is maybe two things. One is that it's the mechanisms that you put in place around reliability that will enable the speed at safety. And we'll talk about some of those mechanisms. And the second thing really is it's as much a cultural thing as it is a technical thing. People focus a lot on tools and blast radius and progressive rollout and testing and all the things you can do. But really, if your engineering teams have that mindset and we prioritize reliability as a feature and safety as a feature, you start to build in the things that enable the team to move fast while really institutionalizing the customer reliability aspect of it. frankly, we didn't do that for a while, and it's something that came to a head about 1.5 years ago, and we went through a pretty large transformation. And as a result, when you talk to engineers, generally we always recite at Atlassian like it's security, reliability, and then KRs, where KRs are features, product, business deliverables, and we're very clear in that prioritization. And we have enabled and empowered teams to say, hey, I need to really focus on operational health here for a little while, and as a result, I'm going to, maybe delay a deliverable or postpone a commitment. And that's a painful thing to do, but it's the right thing using that prioritization matrix. So breeding that into the culture takes time. It takes rewards, incentives, the things you focus on as an engineering leadership team is what your organization will pay attention to. And so, and then augmenting it with those mechanisms that are sustainable and scalable, because you can't rely on, one good individual or one good team when you're 3,500 people all over the world.
So it's interesting to hear the prioritization that you mentioned, because for sure, if you have a set product suite or a product suite that just has a lot of customers, right, that security being of utmost importance and stability and things working the way, it's like regressions are way more impactful, right? Because it's like you're not used to, you're used to things working and then suddenly they break. Like that's a big deal in terms of trust, from the user's perspective. But I'm curious, do you see that that prioritization as something that applies to companies of all stages and sizes, or is it just kind of for folks that already have an established product? Do you think startups kind of should adhere to a similar kind of prioritization, or how do things change when we start looking at different company sizes?
We discuss it quite a bit, because we have, large products like, let's say, Jira or Trello that are used by many, by millions of people. But we also develop new products. So just a couple of weeks ago at our Team 21 Summit, we unveiled a thing called Point A, which is an internal accelerator for new products. And we actually launched and announced a couple of new products. And so we have internal startups that debate that, like, where should we set the reliability bar? And effectively what we say is the brand and the product we're carrying, people expect a certain level of availability and reliability, and just slapping a beta label on something doesn't absolve you of the obligation to run a secure, performant service. And so what we think about again is, when you launch those services, you may change where your P99s are or something like that, to say, or you might not have a big enough team to provide 24/7 coverage. And so you may have to build that into the expectation and the support. But again, you can build process around that and say things like, okay, our deployment processes are different, or we make heavier use of feature flags. So if something does go bump in the night, we just turn it off, because it's easier to turn a feature on and off than it is to debug it in production and to find out why it's not working for thousands or hundreds of thousands of customers. So I think the same mindset applies no matter how big or small a company or a team are. And to some degree, you can still achieve that velocity once you start to build that into the team. I do think there's other areas where you may decide to trade off based on, you're a startup or you're launching, but it really comes down to, I would say, features and feature velocity rather than, pulling back on speed and performance.
So you mentioned, there's one thing I want to call out, only because certainly we have, I'm sure, folks that are at large companies that are listening, but also folks that may be either a new engineering manager, or they're at a smaller organization, or they haven't really experienced kind of that the large institution, if you will. But the feature flags and the ability to like turn on and off individual features, can you talk a little bit more about that, just for context? Because certainly for me, when I embraced that in my past, I found it to be highly beneficial as it relates to speed and quality. And when the quality is like, you can kind of flip it off. If you want to share more color, and then afterwards I'll start going into audience Q&A. So by the way, folks, ask any other questions that you have in the meantime. But
sure. The on the feature flags, I guess the way that I think about it is, across the spectrum of reliability and performance, there's really three domains. There's the build, the domain, deploy domain, and run domain. And in each of those domains, you apply different techniques to instill the culture and mechanisms for reliability. So I would put the feature flagging into the deploy bucket as a way to reduce blast radius. And sometimes feature flagging gets conflated with experimentation, and they're similar enough that you might be able to use some of the tooling and the techniques, but they do have different end games, if you will. One is an operational metric, one is a business metric, typically on the experimentation side. And the other area where I see feature flags getting conflated is with, like, you've got progressive rollouts, blue-green deploys, and then feature flags. So the way I think about it is any new feature, big or small, should go out behind a feature flag. Bug fixes, less so, right? Because typically with a bug fix, you have a more concrete before and after. Now, this is very much a double-edged sword, right? Like I always use the example when I was building and deploying my own software back in the day, I had a staging environment where I could take production, run like if production is version N, I can run staging at N+1, and I can test everything and be confident in my deploy. Now, if you're running a services architecture that's littered with feature flags, you cannot generate a version of N in your testing environment. And so at any one time, what your end users are experiencing may be code paths or experiences that you have not tested. And so you have to think about the units of observability, how you can fine tune that to identify errors within those smaller cohorts. And that's where something like feature flagging is a little bit double-edged. One is you're going to create more of those cohorts, right? Let's say you have 10 services and each has 3 feature flags, and some permutation of those is what a user is experiencing. But the flip side is if one of those 30 flags now happens to, be a bad deploy or have a bug, if you can quickly isolate that and turn it off, you can restore service for that cohort very quickly. So it requires a different angle of tooling, a different lens, and then your testing philosophy also has to change to adapt to, what's happening in production may be something that you've never replicated in a dev or test environment.
That can obviously, I'm encountering this actually right now at my startup, right? The staging environment or testing environment isn't so useful when it's you have issues that only can replicate in production. Yeah. And only
over the years, I think monoliths have kind of gotten a bad name, but there's a lot to love about a monolith. It's something you can reason about. It's something, and so to me, monoliths are perfectly fine architectural approaches for certain team sizes and domains. And so to some degree, there's a lot to like about that because you have less to reason with from a testing, deployment, et cetera. So I think it's something that's super important to think through. I'll add one more point and then we get to the Q&A, which is there's a mental shift I think that engineers have to go through. And I went through this myself as well, where, early in my career, I would work so hard to try to build software that wouldn't fail. And you get to a point where you realize that it's going to fail. And what you need to do is embrace that and say, I will try to prevent that happening, but I have to assume it will. And when it does, how quickly can I identify that and be informed and quickly isolate the fault and fix it through whatever mechanism of fix. So there's a mental shift where you go from how can I prevent to it's going to happen. How can I know and quickly isolate and recover?
That's a huge call out, And the thing that it reminds me of for myself was, the culture of silent failure, right? Which sometimes can exist where, I think about the ways in which this manifests when engineers will, they catch exceptions because they don't want exceptions just kind of running about in the code, right? And so then they catch the exceptions and then they log something to like a debug line and then kind of keep going. Meanwhile, nobody knows about some kind of ongoing bug that exists. And embracing the failure and actually failing loudly enables you to, yes, you have to postmortem. Yes, people may see things, but it enables you to fix the issues, right?
Yeah. And learn too. And I'll touch on this. Hopefully there'll be some questions maybe around the mechanisms where one of the rituals we have is this weekly event called World, where people actually come in and present their incident review. So we actually celebrate the learning and, it's never good to have an incident, but we have people coming in and saying, this is what happened and this is what we learned and this is what we could have done better. And, we typically have hundreds of people dialed in and hundreds of people watch those videos and take those learnings back to their services where, the best incident is the one that never happened, right? Because you found it through those learnings and the experience of others rather than your own personal experience. And so really trying to cascade those learnings out through the teams and the organizations in a blameless way is a really key practice of being able to instill that reliability to the service.
So you're talking a little bit now in terms of sort of I don't know how we say it, like culture, trickling down culture or getting cultural elements out to the company, which leads perfectly into this first question in the Q&A. So Jeremy asks, as you scale, how do you make sure that teams are aware of information to keep your organization secure?
Yeah, it's a really scary question, bluntly, because having been in places where, you know, you can sometimes be popped with 0 days that are not like you can do everything. And so this goes back to the example of there's a prevention and there's a detection. So I think you have to have, you know, a balanced view on both. So there's a paranoia effect, which is even if I did everything, I may still have something that happens and I need to be detecting it. Now, so I would say that's one. On the security side, it's something we've invested a lot in as well. We've worked closely with our security teams to define what we call security scorecards. So we've quantified a set of modules that run through tooling across our code bases, across our infrastructure, in some cases, things like security training, or how many security champions have been, you know, within each team. And we score those, and a team gets a score, and we maintain a minimum number, you know, a minimum threshold. And it's an interesting gamification, because on one hand, teams have to stay north of that threshold, or they have to down tools. Go back to the prioritization. If you're below that threshold, you down tools and go and get back above that threshold. And then the second part of it is our security team are continuously adding new modules and increasing the scope, which means you might hit that threshold and then the finish line moves out. So we're continually trying to hit the bar, hit bar, you know, and stay in that. And then teams can institutionalize that into their planning, into their rituals as well, where, you know, whether it's the on-call person or a disturbed eng can say, okay, I'm paying down some tech debt, or I'm addressing some security stuff, or closing out PIR action items. So like, again, it builds into the cultural rhythm of the team. So I would say, to concretely answer, how do we try to quantify it? So the teams have very concrete actions and targets, and then we try to balance it with that paranoia, which is, even if we're there, do we have the right detection mechanisms in place? So at Atlassian, for example, we use a red team who periodically go, and if you're familiar with the red team model, the idea is you have an internal team whose job it is to try to gain access to your systems, and that's everything through social engineering to phishing to attacking weak passwords and anything else. And that's actually something, again, we celebrate. So when the red team run an exercise, we publish blogs and we publish the learnings, and the teams that were targeted get an opportunity to participate in that and share their learnings. So I would say that's kind of how we do it.
That's excellent. I recall, I wish I remember the company that has like a live, actually, there are probably plenty of companies that do this, that have something live that's running, that's basically actively, for lack of better words, taking down connections and like creating instability to force different parts of the organization to be resilient to that.
That's the chaos engineering from Netflix. I think it's been branded as the Simian Army now. And so we actually run those tools as well in production, which is always a fun exercise to try to, and then you try to scale it up to more and more systems. There are certain systems that are just not built for that, and so we have to isolate those. But certainly, I would say it's a portfolio model where we try to run as many things as we can. For example, I know in Trello, one of the tools that the team used there was they had a continuous tool running in production called Hammer that was taking up 25% of capacity, so that if we did hit capacity limit somewhere, we could turn off Hammer and then quickly find out what was happening and then turn it back on. So we had synthetic load in production to find the limits of the system before our users do.
That's excellent. I'm reflecting on, so one of our software engineers who was working at TikTok not too long ago, you know, prior to the pandemic, they had a habit of planning ahead, you know, as they're scaling up. But one of the things that he had reminded me of, is we're facing our own scaling challenges at this current startup, is scaling, and also like being ahead of the security game. It's one of those things that you may not necessarily get actively rewarded, you know, as you're experiencing the success of it. But
yes,
you know, pretty quickly when you failed, you know, and quite loudly. And kind of what you were alluding to as well, this idea of, you know, it's not a matter of when, but if, if but when, as it relates to a breach or, you know, other type of severe instability. So good call outs. Jeremy has a follow-up question with an example. Actually, example relates to this. A seemingly minor issue in one dev's hands, which they may not worry about, if combined with a piece of information that another dev has, would make that a much bigger concern. I don't know if that inspires you of any stories or thoughts?
Yeah, I think if just to make sure I understand, I guess the way I'm answering this is thinking about like there's, again, in distributed systems, there's some partial knowledge that can be distributed. Again, I think this will happen. I would love to say I have a solve for it. I don't think there is a universal solve, because at a certain point, it's impossible for a system to live in one person's head. You start moving from deterministic systems to chaos systems, and in chaos systems, they're difficult to reason with. So I think that's where it starts flipping to, do you have the right deploy and run infrastructure in place to quickly identify if something is happening and either roll it back or change it, or have the detection in place? So I would say that's a good example where I don't think there's a systemic way to prevent that from introducing something to the system. You would want to lean more on the detection, rapid resolution side of things and say, it will happen. What can we do to detect it and quickly address it?
Makes sense. This next question is from Wesley. Around a culture of reliability and safety, how do you encourage the spread of good practices and behaviors from one team to many teams while maintaining a sense of autonomy?
I think there's a couple of things in there. One is that as engineering leaders, what we pay attention to and what we champion is what our organizations will also pay attention to, and this is something that you pick up over time. There's a couple of particular things that we do. We have so along the lines of autonomy, we provide some tooling. So we have adopted a technique called TechOps that we adopted from Amazon, actually. And TechOps it's basically a team sits down once a week for an hour, and they go through a standard report of everything operational about their service. So they look at the alerts, they look at the key dashboards, they look at error rates, they look at open security items that they need to address, they look at open PIRs. And that is autonomy, because the team get to basically look at their own world and define what needs to get done and what's coming up. And so you have insights that you can plan into rather than reacting. We then roll those tech ops into a tech op. So for example, in a team of, let's say, an engineering manager and 7 engineers in Confluence, they will have a tech ops meeting. We've built tooling that collects up and creates a standard dashboard for those teams. So the overhead of creating that view is practically nil or very, very low. And then we roll those up so that the head of Confluence Cloud can sit down and look at the tech ops across the whole of Confluence and see, are there trends, are there concerns, is there something ticking up? Because it's, when something drops off a cliff, or let's say something spikes, it's very easy to identify that. More insidious is like if you have this, your performance numbers are dropping slowly, or there's an increase in error rate every week that isn't a spike. So how do you get eyes on that regularly? And then we do a roll up of that. And then the other thing we do around the good practices and behaviors is this world model. So once a week for an hour, we have a backlog of people that come in and present. Yesterday, the Trello team came and presented a set of dashboards that they use to view and what the metrics and alerts are. The week before, I think we had somebody doing a PIR on some incident that we had. And so it's a very public thing with hundreds of engineers. Anyone can dial in. It's open to the whole company. And people just present what happened, what they learned, and what they would do. So I think it's that reinforcement of shared learning, empowerment for the individual engineers to share their learnings, and not turning it into a, wow, you had an incident, how could you let that happen? Versus, we had an incident, what did we learn, and how can we prevent that as an organization, rather than isolating the learnings to a single team.
So it sounds like the two sort of types of ways to address this that I'm hearing are kind of frameworks, for lack of better words, and then show and tell, I guess, again, for lack of better words, so that rather than having everything feel like it's like either coming from the top or that it's kind of berating people with mistakes, that people come in with their own problems, their own projects, baggage, so to speak, and are applying a framework to it. Correct. That the consistency of that framework enables the teams to kind of maintain that consistency and to kind of instill cultural elements that way. And then the other way is through, as you're describing, the show and tell of folks showing and describing what works for them so that others can learn. And
it's not magic either. Again, I mean, this isn't something that you flip a bit and all of a sudden it happens. Like, you have to build up that momentum. You have to reinforce it through our engineering leadership team attend those world sessions every week. And participate and ask questions and reinforce that there's value here and it's something that we think is important. And we have a really good SRE team that creates these tools and processes for incident reviews and tech ops and everything else. So we actually invest in the tools to allow the autonomy and scale. And sure, every team could come up with their own, but we think there's value to doing it consistently. And then there's, economies of scale from building it once.
So common questions obviously come up as that relates to this issue of senior managers or people from above who want things to come out the door quickly. And then of course, like on the engineering side, folks who want to deliver that, but also want to maintain the, not only stability and performance, but also not take on a bunch of technical debt because, it tends to be the engineers that often suffer, through having to endure said technical debt. So this question from you, Jean, is how do you instill a culture that encourages engineers to address technical debt without upper management pushback?
It's always tough when technical debt comes up because the definition of technical debt changes. When and how you either incur or pay it down changes. And a lot of that is just knowledge that the team have. I would say there's less around the upper management pushback. The way our teams operate is we have a triad model where we have design and product and engineering leads in a group, and we try to, drive as much autonomy to those teams to own their services and operate and everything else. So within that group, obviously, there's a desire to build features and to launch and improve our users' user experience and things like that. So I would say the culture that we try to instill is number one, transparency, so that there should be a shared understanding across that leadership team of what are the implications of carrying that technical debt. I don't think a product manager or designer needs to understand deeply how it is implemented or how a particular stack is out of date or whatever. But they should understand, look, this is slowing down our team, or there's a risk for reliability, or we're out of date on updating libraries, which leaves us vulnerable to some security attack or something like that. That's something that they should be capable of understanding. And so in there, we try to be very transparent with our capacity planning. So engineering managers it's not like there's hey, I'm going to put 10% over there that you don't need to see or worry about, as much as, okay, we all own the outcomes, we'll win or lose as a team. And this is something you should be concerned about in the same way that I'm concerned about whether our customers are using the product and whether they're happy with CSAT. And so that shared understanding, I think, is key. And in there then comes a trust that the engineering leadership can say, hey, we need to invest a bit more over the next couple of cycles or sprints, or coming up somewhere in the next couple of months, we're going to need to go take care of this dark corner of the service that we don't like to touch, but is becoming increasingly noisy or chirpy because we're seeing it in the error reports, or we're seeing the performance lag. So I would say being as transparent as possible. Don't worry, don't try to explain the technical details of why it's a problem. Try to explain the consequences of what that risk is. And then the other technique we have, if you need it, is a clean escalation. So if you do get to the point where you just disagree, let's say engineering teams feel, look, we need to go do a thing, and for some reason they're not empowered to do it, then you can use a clean escalation technique where you can basically converge it, whether it's the engineering leadership, and say, this isn't about David is right and I'm wrong, or he's good and I'm bad. It's about, I think we should do X, you think we should do Y. Can we articulate the trade-offs and the risks? And we need somebody to make a clean decision for us. And then at least you'll hear, you'll feel heard and understood, even if you decide to defer tackling that tech debt. More often than not, when you go through that clean escalation process, you end up closing out a decision before it gets to the escalation point, because you realize that you were talking about something different, or your trade-offs were imbalanced. And just having that conversation cleanly on a piece of paper helps kind of debug that.
So you touch on a lot of topics that now get into a little bit of kind of the interpersonal human dynamics piece of the equation, which, right, as we get more senior, turns out that the job is way more about that than necessarily about the technical. And part of what you mentioned, I'm reminded of, is kind of this idea of making the pain personal, for lack of better words, and that when you transparently communicate what's going on for you or your team, and like who might be experiencing really rough times, or the potential users that might be experiencing rough times, that the more personal that pain is, the more folks can effectively work together. The other thing that I think is interesting that you bring out is, there's some folks that have a little bit of this philosophical, I say this actually because I share this belief, but that if two people who are both reasonable people have the exact same information and context and background and everything coloring their perspectives, that they will always draw the same conclusion. And so when they don't draw the same conclusion, it's usually because there's either a very different context known or background or piece of information, et cetera. So it's good to hear that the
I definitely
escalation path is sometimes always necessary.
Yeah, I mean, escalation is not necessarily a bad thing. In some cases, we want to encourage as leaders earlier escalation to unblock teams or to reduce friction. But there's definitely two things. One is, are we saying the same thing? And then the second thing is, are we, like, if you think about the trade-off sliders, are we positioning the sliders at the same point? And if you do those and you're all aligned, then it's very rare that somebody needs to make a decision versus, oh, I was optimizing for cost and you were optimizing for time. Oh, okay. Now maybe we can decide amongst ourselves that it's a different point on the slider. And then this is where, coming back to the reliability thing, this is where you can establish some, let's say, non-negotiables around, look, if this is going to take our P99s down from X to, X minus 10, that's just something that we as an engineering org don't consider acceptable. Or, we can't do it unless a follow-on thing happens within a defined amount of time that David, you and I would agree on, and it becomes non-negotiable. So you get to bring that into that conversation as well.
So this topic of technical debt has kind of, I think, sparked some upvotes. So a follow-up question from you, John. Do you have any ideas on how to measure technical debt to clue product management to let off the gas pedal for the next release?
The short answer is no. And we tried to come up with things like, we have some heuristics, I would say, like, in some cases we would look at, commits to a particular code base that we consider, monolithic or legacy, something like that. But we haven't found a magic number that we can assign to tech debt, be it a percentage or something else. There's too much context that gets lost in, 42 that you try to then explain that to somebody. So short answer is no. We haven't found a way to quantify technical debt that makes it actionable. And if you think about the best metrics are the ones that you can drive action from and try to drive down. So to me, the question about, like, with product management, what I found is more successful is less quantifying and more explaining the consequences of, or the potential risks. And the earlier you can do that, the more you can naturally fit that in. Now, I'd like to tell you, I'd love to tell you we do this well and everything is great, but we absolutely have situations where a team is like, crap, we've just hit a wall and we need to, like, sorry, we committed to doing this work for the next month, but we just need to go firefight this reliability thing that popped up. And again, I don't think anybody on the team would be happy about that, but we have institutionalized a way where teams can do that and get air cover for it. We use terminology like 2-alarm fire and 3-alarm fire to kind of dictate, if something is happening, a team needs to go and address it, and then define the exit criteria for that and when they think they can do it, so that teams are able to kind of institutionalize making space. But again, you want that to be very rare, particularly at the team level, and you want to retro that afterwards to say, how did we get to that point? And, is there something we can do to prevent it happening again?
It makes sense.
That learning loop is key.
Sure. I'm relieved. I imagine some folks listening may be relieved to know that if you are who's running the engineering team at Atlassian is sometimes not able to quantify and create from quantifiable metrics into action every little piece of the job of a senior engineering leader, it's good to know that others
don't confuse that with it doesn't annoy me, and I will continue to try to quantify it. And we try to use, there's other things then to you, John's point about, we use some proxy metrics like PR cycle time that we will provide to teams to say, if your PR cycle time is creeping up, can a team use that to retro, why is it creeping up? And it might be because of technical debt. So again, tech debt itself is a what, it's not a the consequences of tech debt are really what you want to watch out for. And so if there's symptoms of that, like it's getting harder to contribute code to the monolith because I just can't reason with it anymore, or our test coverage is ineffective because we claim we have 80% test coverage, but we launch and we're continually rolling back, they're better conversations than so you can use input metrics like those, but the output metric of quantifying tech debt is super hard. I would love, if someone has some details on that, I would love to learn.
There you go. The only thing that I can reflect on for myself is that in the making pain personal front, right? I think folks are familiar with taking engineers and showing them or putting them into a user study group so that they can see and feel the pain of, if there's a user experience thing they're not so excited about, for example. But I wonder about the reverse, which is the executives and or product folks and or design folks that may not really feel or appreciate or understand the impact of how technical debt is impacting an engineer, who's maybe going through a spaghetti code base that makes them die inside every time that they work and have trouble being productive. That, maybe a conversation in that regard could be helpful as well.
Yes.
Kind of switching things around. It's fascinating. This next question from Doug is, how do you define quality, and how does your internal definition align with your customers' expectations of quality?
No worries. Hi, Doug. I think I know Doug, actually. Cool. So there's a couple of ways. It is correct that you have an external view of quality, which we'll typically describe as SLAs, right? So around the system. So the way that we quantify that is we have defined some core journeys. So for example, logging in Jira, creating an issue or updating an issue. So we have these core user journeys, and we warrant then that they will be available at a certain percentage, right? So be that 99.9, 99.95, whatever number you decide. In some cases, those are contractually obligated. So depending on what your pricing model is or what your licensing model is, you can become contractually obligated to provide those capabilities at that level. So we define that, we measure it using a certain set of things. And so we have synthetics, we have error codes, front end, back end, etc. And so we define something there that we feel is a real representation of the customer experience, because I don't know, we've worked in places where the synthetics are 100% and the site is down. So you kind of have to find a balance between synthetics and then actual user metrics as well, user level, user monitoring. So that's how we do kind of the customer level. Internally, then we think of those capabilities as being built up of a set of services and API endpoints. So each of those, if you think about the services as being horizontal, we define availability metrics. So what we do at Atlassian is we have defined services between tier 0, 1, 2, 3. And when your service is built, you have to say which tier it sits in. And in that tier, you have an obligation. So, and typically your obligation has to be higher than the public one, right? Just math. If you multiply the permutations, if you're going to give 99.9 to a customer, then you need higher permutations underneath. Or you may need to architect solutions for high availability and rapid failover at scale and so on. But each of those services have endpoints that are measured and maintain their availability. And going back to that tech ops example and the monitoring and observability, we monitor and review those very carefully, and in some cases alert if they drop below certain amounts. And then we have internal measurements then of to recreate that customer obligation of, let's say, 99.9 or 99.95. We say, okay, the customer journey of Jira create issue, we measure that from the outside in, what's the user experience, so that we have our own internal metrics, and we look at that by different cohorts. So we look at it, for example, where we have enterprise customers with more than 1,000 users, they may have a different experience than someone with 3 users in their instance for performance or timeout or whatever it is. So you have to kind of look at different slices and dices. So externally, we look at the SLOs and the SLAs, and then internally, we make sure we have different measures. I'd love to say we have a direct ladder between them that you can connect this API call to this measure, to that thing, to this. It's not quite that clean. We're continually trying to build those connections.
The underlying component of everything you just described that I hear is to be explicit and to communicate that explicitly. And, in certain situations, particularly early stage products that maybe are less API driven and more let's say a mobile app or something, that yes, the interpretation of what quality is easily led, it's the eye of the beholder, and being more explicit can at least help you. Yeah,
that's a great example. For example, in mobile, you're probably measuring your P90s instead of your P99s or P99.9s. So you need to apply some critical thought to that environment and understand what's happening.
Totally.
So and again, I'd love to tell you that people come in and they have all of this figured out. A lot of it is true experience, and it comes back to, okay, if we didn't get it right somewhere, can we quickly kind of apply those learnings more broadly and just improve and tighten up? So that continuous improvement is also key.
Makes sense. We have another question related to technical debt. This one from Jan. One way some teams go about tech debt is dedicate a percentage of their capacity, say 30%, to tech debt. What's your opinion on that practice?
We don't do that. What we do is we ask teams to, we don't do time tracking. Like we don't say, hey, how much time did you, today did you spend on X or Y? So the course level of a team, we do some measurement around how much time are you spending on keep the lights on? How much time are you spending on admin activities like interviewing, training, vacation, stuff like that. And so what we ask engineers to, and engineering managers to do is when you're building a quarterly plan, obviously we do sprint planning as well, but when you're building a quarterly plan, which is typically our planning horizon for that level of team, bring that into your capacity plan and say, okay, if I've got 10 people in 13 weeks, that's 130 person weeks. Now discount for your KTLO, discount for your admin. And so in there, then if there is some time that needs to be spent on burning down tech debt, we will put that on the table as something that we put with the product managers, we prioritize, we put it on the list in the same way we would a task or a feature. So it goes back to that transparency thing of if you need to do the work, it's better to bring it up and explain why. I have in the past been at places or I've seen things where teams are just like, look, I'm just going to take 30% to deal with tech debt. And in some cases, the product managers are relieved because they're like, techno mumbo jumbo, that's fine. You do what you need to do over there. But over time, I think the more transparent you can be with that and then tailor it based on what you might have, I'll make this up. You might have an event coming up in a couple of months where you need features to be available, right? And in there is probably not the best time to say, hey, we're going to take this 2-year tech debt and kind of disappear for 2 months and deliver it. So that transparency helps the teams have a shared understanding of what winning means for the teams.
You're servicing a topic that I'm hearing a lot about these days, which is effort versus impact.
Yeah.
And that we so many times we quantify and we measure our effort and something like 30%, it's technical that it's like 30% of the effort, but it's the impact that matters. So what you're alluding to about prioritizing the impact of whatever that specific technical debt work is, along with the other product impact and other things that can be impactful, that's really maybe a more effective way of approaching it.
And it's easier for folks to connect to that impact as well. It can be harder to explain. And again, it sounds very clean. Like in here is human relationships and trust as well, that between the different leaders in the teams and the organizations, and that trust comes over time by repeatedly working together and getting that rhythm down. So in some cases you have to lean on that to say, I'm trying to explain, I'm explaining why, but it might come down to a point of like, you just need to trust me on this one, that like this is going to bite us and we need to take it on now.
There you go. This next question from Tina is probably a common one, which is what key performance indicators do you use to report to executives?
It's probably the ones I mentioned before. So we have different views of our SLA attainment, because that has in some cases financial consequences, right? Like if we've agreed to hit certain availability and reliability. Across our engineering leadership and our product leadership, we have a set of engineering health metrics. So we look at things like the security score as one, availability metrics, things like escalations from support. So we have set SLAs with our support teams. So we have engineering health metrics. Frankly, we haven't standardized that in a single view that everybody uses, but some combination of like the same 6 or 7 metrics are used across all the teams, and then they become their engineering health metrics. The other part there, Tina, that's interesting is we report those on the same pane of glass that we do our business metrics. So when we send out business metrics, we include the engineering health metrics in there to say that, there are eyes on those and we consider them important.
Excellent. So this next question, I'm going to see if I can pronounce it correctly. Pradnya. Is there anything like too much logging and monitoring in production? And does it help reproduce the issues on the staging environment?
There's kind of 2 questions in there. Is there too much logging and monitoring in production? If you can't figure out what production is doing, then yes. And the other consequence, obviously, of logging and monitoring is cost and performance, right? Like, if you're logging everything across a massive fleet, that has cost and scale implications. And so you might need to do it because, and we do, crazy amounts of logging. I would say There's never too much monitoring in production. I would separate that. Like, how you monitor your observability, your metrics and things like that are absolutely key. I do know in some places where and again, it varies by system. If you have very stateless systems, for example, let's say you have a fleet of 1,000 stateless containers, you could monitor a container and say, if that container goes bad, I'll just take it out of the fleet. And instead of monitoring all 100, you could just sample, right? So you can reduce the logging, but your approach to your reliability architecture then has to change as a result of that. What we see as ways to manage the logging explosion is things like distributed tracing with different sample levels, as well as looking at metrics and anomaly detections across the fleet. So there are some techniques. Does it help to reproduce the issues on staging? Absolutely. I mean, if you can deterministically reproduce an issue, you can deterministically fix it. And so you always want to try to do that. And you never want to end up in a state where an engineer is like, well, I can't test it, so I guess I'll release it and see what happens. Like, so there has to be some level of rigor around your unit test coverage, your automation, your deployment, your bake times and things like that. But ideally, yes, you would be able to deterministically test something in staging, even if it's within the realm of just, an API down in a mocked environment. At least you can test for, expected and anomalous behaviors and make sure that your system behaves as you would expect.
So we've talked about security, we've talked about reliability, we've talked about performance, and of course, all of these tie directly into quality. And I know that we've already kind of covered this question a little bit, but I want to see if any other nuggets that we can pull out. So this question from Wesley: around a culture of reliability and safety, how do you encourage the spread of good practices and behaviors from one team to many teams while maintaining a sense of autonomy? We touched a little bit about this before, but if you have any other additional thoughts or reflections.
Yeah, I think we hit on that one. I think it's really those providing the tools and the insights because the teams know their services the best, but then trying to roll it out in a more consistent way across your fleet of teams, if you will, because that also allows the shared learnings to transfer between the teams more easily.
Great. This question from Rajat is, we spoke about chaos engineering and being mentally ready to face things going wrong on production. How important are initiatives like observability in this regard?
They're critical. I mean, observability is, especially, and again, when you think about the transition from monoliths to microservices, and I shudder when I say microservices, but hopefully everyone in this audience understands why. So like, as you start to decompose, observability is king. Like if you go back to that build, deploy, and run, observability is the thing that will reduce your time to detect, right? So if you think about an incident as being incident, time to detect, time to resolve, you can attack different parts of that, but your observability is reducing your time to detect, which will reduce your overall incident time. We invest very heavily in observability, probably not as much as we should, because it's just a huge area, a huge surface area, and there's so many different angles to it. I would just say, how important, they're critical, absolutely critical, to invest in observability, and also know the angles that you're looking at, front end versus back end, different cohorts, thinking about trace, samples versus, full, alerting off of metrics, not off of logs. So there's a ton of learnings in there again that you would need to experience. And so the more you can bring in from other people's experience, the better. So maybe the advice there, Rajat, is like, go talk to as many teams as you can in and out of your company and take as many of those learnings as you can.
So we have a little bit over 5 minutes left, and there's would love to step back just a little bit. Given that we've talked about a lot of things, I think the second question from Rajat is quite a poignant one in that regard, which is, what would be one piece of advice in the context of being, plenty of context I'm sure we could pick from, but the ones relevant to this topic, what would be one piece of advice you would give to your younger self?
It's hard to boil it down to one.
Maybe you can, if you remember, like, it's easier to recall trauma. If you recall a really, really bad postmortem,
I'll give two. One is personal: play less football. My neck would hurt a lot less. The second one is on the other. I think it's the thing I touched on earlier, which is having that realization that you should spend as much time on the detection side as you should on the prevention side. And that will save you a lot of pain. Like when I think about, what the long, and everyone has it's a favorite interview question of mine, which is, tell me about your most painful incident. And you just get like, when really good engineers, you'll hear them viscerally time travel back and explain everything that happened and the command line they ran and the root cause, like that visceral experience. And when I think about my most visceral experiences, I probably could have avoided those if I had spent more time on the detection side. Whereas we were so focused on the prevention side that, you know, finding the balance, I think would be key in the context of this.
Yeah, sure. It's an excellent lesson. I think we all, you know, as engineers, we don't always talk about emotions, but so many of us have experienced the PTSD, for lack of better words, of horrible outages.
I could see your face even when I brought it up. You're thinking about that war room and you're like, oh, that sucked so bad. Totally.
I mean, part of this is, my startup is in its own, you know, c'est la vie, but yeah, we all have these things surface, you know, from time to time. So in the few minutes that we have, just going back to some other questions, this question from Yidner is, do you use any methods or algorithms to prioritize your tech debt? And do you maintain a separate technical roadmap? We talked about this topic a little bit too, but if you have any other reflections.
We don't use algorithms. I mean, what we use is really the insights from the observability, going back to that question from Rajat around like, what is the health of the system? And we use those as input metrics to make those decisions. So we don't have algorithms. I guess you could think of like, you know, calculations across errors or something, or security scorecards as a form of algorithms, but they become leading indicators of when we need to really kind of invest in paying down some debt or getting ahead of some lingering problems. I would say on the separate technical roadmap, there's two parts to that. Within a team, we try not to. Like, again, I would always advise being very transparent on the roadmap. So if there are technical things that need to get done, it should appear on the same capacity plan, on the same delivery. It should have the same celebration when it ships as a feature and everything else. And that kind of elevates everything about that. Now, as an architecture team across the whole organization, we may end up having like a technical roadmap around either particular architectures or technologies we're trying to roll in, but even there, they would have a roadmap.
Excellent. So we have time for just about one more question. I'll just pull this one out of my invisible hat, which is, we've talked a lot about quality, and we talked a little bit about the speed side, but maybe just to touch a bit more on the speed side, if you have any reflections for yourself on a top recommendation or reflection as it relates to improving speed in terms of just getting stuff out the door. If you have any top recommendation or two for folks.
One is, data is king, right? So observability and being actually able to report on what the real user experience is. So you hear about RUM all the time, like real user monitoring. So, and being able to split it. So one is measure it and make sure you're looking at the right cohorts for your measurement. The second thing is thinking about the difference between availability and reliability. So for example, availability might be an API responds with a 200. Reliability might be it replies with a 2xx or whatever it is, or sub 400 in less than 4 seconds. Right? So you can bring performance into your reliability and say, okay, we might have replied, but we're going to set our, if we think about the SLAs and we think about the reliability of a service, it'll basically count as a tick against you if it's outside the acceptable performance. So again, the more you can measure and then integrate with your standard, reliability, availability, it gives the teams the techniques to look into it. Again, it's an area we've spent a ton of time on. You want to talk about all the where the front end technologies are going and bundle sizes and all of that. Like there's so much wrapped up in that, but until you can measure it, it's conjecture as to what your problems might be and how to address it. So I would say invest heavily in that upfront observability part of performance.
So we've definitely heard a lot about measurement today, observability, not only prevention, but detection. These are all great words of wisdom. So with that, Steve, I want to thank you so much for taking the time to share your wisdom with everyone. Again, your background is incredibly impressive, and your wisdom as well. It speaks for itself. So I know everybody listening is grateful as well. So I want to thank you again for your time, and wish you a wonderful rest of your day.